So as far as solving for exponents using this chart, the easy ones will be just something that's directly from your chart. 5 to the x equals 125. What's x? 3, because it's directly from your chart. The ones that are medium are going to be ones that are on your chart, but it might look something like this. 8 to the x is equal to 32. Well, 32 isn't in your chart of 8s. So then we have to look, is there a way to write 8 and 32 with the same base? Do 8 and 32 happen to be in the same column as one of these bases? And they do. They're both powers of 2. So what we're going to do in those ones is we're going to change 8 to 2 cubed. We would still have the power of x here. We would change 32 to 2 to the 5. And then we're going to have to think of our exponent laws. What exponent laws do I have here? What happens when you have an exponent to an exponent? Exponent to an exponent, multiply. And now, once you get to the place where both are the same base, does it make sense that inside the blue circle, if these are going to be equal, the blue circles have to be equal? And if that's the case, that means that 3x has to equal 5 divided by 3. And you find out x has to be 5/3. Those are medium ones. The hardest ones are going to be ones that use all of our exponent laws. So before we get to any hard ones, it's probably not a bad thing to also, where you have space, do a little bit of a review of our exponent laws. What's an exponent law you remember? Multiply. So how does that, the one that we just did? The one that we just did. Okay, so if you have a power to a power, so if I have x cubed to the power of 5, that's a power to a power, then you multiply your powers and you get x to the 15. That's one of our exponent laws. Good. What's another one? Quotient law. So if you have, if the bases are the same and you're dividing, what do you do to your exponents? You subtract. The opposite of that one. So if you're multiplying, and this only works if the bases are the same, then you add the exponents. Good, another one. I can think of another 3 or 4 more exponent laws, so keep thinking. There's more. It's the root ones. What happens when you have the cube root of x? How do you write that as an exponent? X to the 1/3. Square root would be to the 1/2. Good. What about this? Well, it's equal to 1. Good. Are you guys like you're done? Can't think of any more? What about x to the minus 2, how can you write that? One over x squared. So your negative exponent rule. How about if you have a couple things multiplied inside? Right, that'll be, I mean, you could, I guess, technically do the same thing with now, we've written these exponent laws with examples. But the key thing to notice in these examples is sometimes you need the bases to be the same in order for the exponent law to work. And that was true for the first three. Well, for the second one and the third one. When you're subtracting or when you're adding, the bases have to be the same. For the other ones, especially at the end when you're multiplying inside, the bases didn't have to be the same. So we're going to have to know our exponent laws well and our powers chart well in order to solve a bunch of questions. So now we can go to example 1. And we can look at part A. Think about our powers chart. Do these happen in the same column? Which column? They happen in the same column in 2. Any other columns? They also happen in the same column as 4. So you have some choice here. And it wouldn't be wrong to change them both to 2, and it wouldn't be wrong to keep them both with 4. So if I kept it the same with 4, I'd have 4 to the x equals, and 256 is 4 to the 4. Now my goal is to get both sides to be the same base, but on the right-hand side, that 4 is on the bottom of my fraction. Yes. So the question is, how could I write this side with a 4 not on the bottom? 4 to the negative 4. And so we're going to use all of our exponent laws until we get to this point, where you've got an equation where both sides have the same base, and if both sides have the same base and they're equal, that means that the exponents must be equal as well. And in this case, that means that x has to equal negative 4, and we're done. Same strategy for the second one. We look at our numbers. The bases are 27 and 9. Do those happen in the same column in our powers chart? Yes, for 3. So we take 27, we change it to 3 cubed, we still have an x up there. We take 9, we change it to 3 squared, we still have a 2x minus 1. What exponent law are we looking at? A power to a power. What do? Multiply. So this one becomes 3x, and when we multiply here, we'd have to distribute, we'd get 4x minus 2. And you see that we've succeeded in getting the bases the same. So if the bases are the same, then these exponents have to be the same. Now, unlike the last one where we could just say the answer because it was just x equaled negative 4, we still have some math to do because now 3x has to equal 4x minus 2. I could put those like terms together, subtract 3x on both sides, add 2 on both sides to get x by itself, and then we get x is equal to 2. All right, take some time to try those.